Hey students, let's study Bethe's law in today's learning bite. Bethe's law says, when an electron beam moves from low potential to high potential, it bends towards the normal. It's about electron refraction, like we have studied light refraction. To make the electron travel between varying potentials, consider two metal grids with two different potentials, V1 and V2, such that V2 greater than V1. Thus, when electron is inserted from the top gap, it travels from low potential to high potential. Consider, initial velocity of electron is small v1, which can be resolved into two components, v1, sine theta 1, along horizontal, or x, and v1, cos theta 1 along vertical, or y. Remember, the electric field is along y direction. This vertical electric field will act on vertical component of the velocity of the electron, making it accelerate along vertical direction, causing increase in y component of velocity, while x component remains the same, as there is no force along x. As y component of velocity has increased, but x component remained the same, the resultant velocity shows a shift towards y, which makes the beam bend towards the normal. This is Bethe's law of electron refraction, like light refraction. Mathematically, it can be expressed using unchanged x components of velocity. As there is no force along x, v1, sine theta 1, is equal to v2, sine theta 2. Thus, rearranging the similar terms on same sides, we get sine theta 1 upon sine theta 2 is equal to small v2 by small v1. Further, using relation between velocity and potential, we get sine theta 1 upon sine theta 2 is equal to small v2 by small v1 equals under root capital V2 by v1. The main points to remember here are, potential is increasing, so velocity of electron also increases. And thus theta, which is angle between direction of electron and electric field, decreases as electron beam bends towards the normal. Let's now talk about similarity and difference between Bethe's law and Snell's law. Similarity is, in both the cases, the beams bend towards the normal, while difference is in the formula. The right-hand side has a reversed velocity ratios. This was all about electron refraction. I hope you enjoyed this learning bite. Next video will be on the use of Bethe's law in electrostatic lens. See you. Subscribe and share the channel with your friends if you like it honestly. Thank you.